Thank you everybody for joining us. This is a presentation on asset inventory and mapping for small water systems in Colorado. If you have any colleagues who cannot join today, we will also be doing the same presentation on the 18th if they're interested in joining, but we're also recording this so they can find it online as well. And after the webinar, I will be sending around the slides for everyone. That's usually a question that we get asked pretty often. But who are we? We are the Southwest Environmental Finance Center, and we're in Albuquerque, New Mexico. We are located at the University of New Mexico in the School of Engineering. And my name is Haley Hajic. I'm going to be helping out our presenter, James, today. So I will be monitoring the chat box and answering any questions that you might have throughout today. This presentation and this webinar is brought to you by the Environmental Finance Center Network, which we are a part of. It's a university-based organization that was initially created by the EPA. And so now we have centers in about almost every EPA region. Technically, we are part of Region 6, but we do trainings and webinars in all regions and territories. And each center specializes on a couple of different subject matter. Ours is asset management, water loss, regionalization, and as part of that, there's mapping and inventory, which is what we're talking about today. And this training is part of our Smart Management for Small Water Systems program. And so each year we do at least one training in every state based on a topic of their choice. So we contacted the folks at your capacity development office in Colorado and gave them about 15 different options, and they got to pick what they felt would be the most useful for small water systems, which is how we ended up with asset inventory and mapping today. We also, besides trainings and webinars, offer technical assistance, and we have a blog that you might also find useful, but this program is free of charge. Again, we're funded by the EPA, so think of it as your tax dollars at work. As I mentioned, we're part of a larger Environmental Finance Center team. Here are all the environmental finance centers. You can see most of them are based out of universities, except for EFC West. They're in California and they're not based out of a university. But we also partner with a lot of organizations like AWWA to help us put on these sorts of trainings. We do, our center specializes again in asset management and water loss and a couple other things, but on the screen here you can see that there are several areas of expertise that all of the centers focus on. So if you're interested in any of these areas, please contact your capacity development department, and in the future when we put on trainings, we can focus on a different area of interest for anybody who's on. As I said before, we do offer technical assistance. It's completely free and it's up to 20 hours of technical assistance. It can be in any of the areas that I just showed you on the last slide. So if you're interested, please go to our network website, which is www.efcnetwork.org. And if you click on the assistance tab, there's an area where you can request assistance and just describe maybe some issues that you're having, and they will connect you either with us or another EFC that specializes in the area that you need assistance in. But we highly recommend that you take advantage of this. We really enjoy doing technical assistance and working one-on-one. So finally, just some reminders, because we are always asked about credit. This was approved for 0.2 Colorado training units for water, wastewater treatment, water distribution, wastewater collection, wastewater treatment, and industrial wastewater treatment categories. So you will be getting credit for this. Make sure that when you sign up that your ID number was correct. James is also going to go into a little bit more detail about the chat feature, because that's where you can send in your questions. And then that's also where I will be putting in some handouts as we go along. James is going to let me know, and I'm going to upload some relevant handouts that you guys can then either view at that time or feel free to download, and we encourage that you save them. So with that, I'm going to hand it over to James, and he's going to start sharing his screen. James, let me know if I need to stop sharing mine for you to be able to share yours.
I should be able to just take over. One second. Can you verify that the right thing is showing?
Yep, I can see it.
Okay, great. Thanks everybody for joining us. In general, we're going to be muting participants, except for maybe at the Q&A piece at the end of the day. But we are going to be using the chat feature several times throughout our training today. So if you look on your Zoom screen, it's sort of down there in the middle. There should be a chat button. If you can't see it, if you make the window wider, it will usually show up. But if you click on that, you should be able to use that chat feature. And just to make sure everybody knows how to do it while I'm introducing ourselves, if you wouldn't mind typing in your name and your organization and your role, and then maybe what you're looking forward to doing as summer is coming. And just to get yourself familiar with it. I know we've been, in the last year, we've been using a lot of different online programs. Zoom seems to be one of the ones that most folks are using, but not everybody has familiarity with these. So if you wouldn't mind just typing something in there as I'm going, Haley will monitor, and I will sort of continue with the presentation while you guys are doing that in the background. And I am going to turn my camera off here just because I hate looking at myself while I'm doing these. All right, so as Haley said, we're from the Southwest Environmental Finance Center, which is part of the EFC network. We're a multidisciplinary team that has engineering, water resource, teaching, computer programming, GIS, accounting, and other backgrounds. And we're part of the University of New Mexico Civil Engineering Department in Albuquerque, New Mexico. In the center here, you can see our mission statement, which is that the Southwest EFC promotes self-reliance through innovative training and assistance focused on actionable results. And that's really the core of our ethos, developing capacity and self-reliance in utilities, particularly small utilities. It's the sort of teach a man to fish approach rather than doing the fishing for you. And I can see people's chats coming through. So thank you everybody for participating in that and making sure that you've got access to that. As Haley said, my name's James Markham. I've been with the EFC for about 5 years now. I've got a background in engineering, operations management, and law. And when I'm not traveling around, or more recently sitting behind a computer screen doing training and technical assistance, I'm usually in my basement building guitars, which I unfortunately build better than I play. It's one of my more recent creations that you're looking at, and it's actually hanging on the wall behind me. If you looked at the notice, we were supposed to have a second co-presenter, Luke Andrews, who is our resident GIS expert. He and his wife just welcomed a new addition to the family, so he's not going to be joining us today. I'll be presenting both the inventory and mapping sections. I do a lot of GIS work as well, but we do have a mapping video at the end that Luke put together for us. So he'll be with us in spirit, if not in person, today in the second half of the presentation. I'd like to remind you to use that chat feature to type in questions as we go. Haley's going to be monitoring the chat while I'm doing the presentation. If there's something that she thinks is important and needs an immediate answer, she'll break in for clarification. Otherwise, in general, we're going to leave the Q&A to the end of each segment. So we'll do the inventory piece and then Q&A on that, and then we'll do the mapping piece and the final Q&A. So with that background, let's get into an overview of asset management. So today we're going to be talking about inventory and mapping in an asset management context. And although we're going to discuss those two things somewhat independently, I think you'll see that they're very related and that they build off and support one another. And just so that we can place these activities within the larger sort of asset management context, I'm going to give you a very, very short overview of asset management in general to start us off. For those of you who've attended any of our asset management trainings over the years, or trainings put on by others, these concepts in the next few slides should look pretty familiar. For those of you who are new to the world of asset management, this will be a very brief introduction so you can kind of frame what we're talking about today. So what is asset management? The definition is that it's a framework to provide the desired level of service at the lowest life cycle cost. What that means in English is the desired level of service is what you want your assets to provide. And the lowest life cycle cost is the best appropriate cost for your system with your particular set of economics. It's really designed as a sort of holistic approach to help you decide how and where to spend your money to achieve your goals for your particular utility, whether it's a drinking water or wastewater or any other kind of business. I actually used to work in the chocolate industry many, many years ago, and we did asset management there as well. And this kind of process is really necessary when you've got a situation like most utilities are in, where you've got competing priorities and limited funding. In its simplest terms, asset management can sort of be thought of as applied common sense. Sort of expanding on that idea, asset management really helps you answer 5 important questions about your utility. First one is, what level of service do you actually want to provide to your customers in terms of water quality, pressure, things like that. The second question is, what assets do you have in order to do that with? The third component is determining which of your assets are most critical to providing that service. The fourth question is, how do you ensure that your assets do their jobs over their lifespans? And the last one is, do you have enough money to get all of that done? So taking those questions and sort of attaching them to the asset management core components, their level of service, current state of the assets, asset inventory, which is what we're going to be focusing on today, criticality or risk management, life cycle costing, and finally, long-term funding. So each of those questions really kind of corresponds to one of these 5 core components that we sort of use to organize the asset management framework. And although I've been talking about this and have sort of laid this out in a linear fashion, it's really not a linear process. It's not something that you go through once and stop, although we sometimes see that approach, particularly when a utility has developed maybe an asset management plan as part of a funding package, and then the plan gets set on a shelf and doesn't get used. Asset management is not just a document, it's an approach for running utility. It's not a linear sort of thing. It does not have a beginning or end. The idea is that you start wherever you're at. You can't be responsible for the past because you can't change that, but you can use the past as a learning opportunity, both in things that went well and things that didn't. We like to talk about asset management as being a journey, not a destination. And the idea is to sort of start where you're at and move forward and develop better practices over time as you grow your processes. And although there are computer programs that are going to help you with asset management, and some of them are even called asset management programs, they're not going to do all of the work for you. They can track a lot of the data, but ultimately you as the utility managers and operators and staff are the ones that are responsible for making those critical decisions. And what asset management helps you do is look at everything in sort of a holistic and unified way. We have a really great resource available on our website, and we will send out a link to this with the follow-up email that comes out with the slides, which is called the Asset Management Switchboard. And it's basically a collection of all kinds of asset management resources. It's a really good source of information on asset management benefits and the 5 core components and how to get started and taking things to the next level once you get going. We even have an online asset management manual that's specifically designed for small water systems that we developed a few years back with the state of Kansas called AmCan Work. It's a great resource. It's online. It's free. You can download it from here. So just a little plug for a really good resource, whether you're just starting out in asset management or you've been doing this for a while. So as I said, very, very short introduction. Today, our focus is really going to be on asset inventory, which in asset management speak is called the current state of the assets. And you notice I have a little tagline on here, supporting operational analysis and data-informed decision-making. And that's really what this is all about. If you don't take anything away, remember that phrase. And I used data-informed there on purpose. We often see the term data-driven decision-making But I think that implies that the data always drives the decision. And one of the things that asset management really tries to focus on is the fact that you use the data, you've got competing priorities, you have to make the decision. So the data is going to inform you and inform the decisions that you make, but it's not necessarily going to make the decision for you, because you're always going to have conflicting priorities. So current state of the assets, what is it? Well, it's our way of talking about the asset inventory. It's really the foundation upon which everything else in asset management is built. And one way to think about what an asset inventory is to really think about what an asset inventory does. And fundamentally, it answers a couple of basic questions. First one being, what do I have? The second being, where is it all? And then the third question is, what do I need to know about those assets? And it's this last bit, the details, that's really the most important piece of your inventory. A robust inventory is much, much more than a list of things the system owns, although it can start out that way. But to be really useful, an asset inventory has to contain enough information to support operational analysis and data-informed decision-making. There's that phrase again. And I think by the end of this section, you'll understand the basic data points you need to collect about your assets in order to accomplish that goal. And you also have some information on tools that you can use to collect that data. And then we'll look in the second half about how to transform that data into really useful maps. So let's talk a little bit about these questions. So first important question is obviously, what is an asset? I think this picture here provides some good examples. We've got, wellhead, treatment equipment, pumps, distribution line, valves. Basically, an asset is anything that you own or manage that has value. And the or manage is important, particularly because in some cases, particularly with stormwater systems and things like that, you might actually be managing assets that you don't actually own. So you have to think about both of those things. The second important question, obviously, is where is everything? Where is it located? Location is, of course, critical because once you know what assets you have to be able to find them in order to perform maintenance and assess them periodically and eventually rehabilitate them. There's a lot of ways to track location, addresses, map grids, but GPS coordinates are really the best way to go, particularly now since it's relatively inexpensive to get accurate GPS equipment. In fact, we're all probably walking around with a GPS device that's good enough to do what I'm talking about today in our back pockets, and that's a smartphone. I think this next slide shows why a GPS coordinate is really important. These are two pictures of the same hydrant from slightly different angles. It's kind of hard to see in the left. This is in early spring here in New Mexico. A couple months later, you're not going to be able to find that hydrant at all. And you really want to be able to find those critical assets. If there's a main break, you want to be able to find the valves to shut it off. Even meter boxes often get lost in rural areas, or when a disaster strikes and the landmarks that you use to find things aren't there anymore. Sure, in a city, most of the meters might be directly in front of a house, but here in rural New Mexico, we often find that that's not the case. Right now, we're actually working with a system in New Mexico that had the same operator for 60 years, and he recently passed away. They charge flat rates for water because their meters, and because of that, they rarely, if ever, read meters, and they've lost track of almost all of them. They literally don't know where 95% of the meters in their system are, and have had to resort to metal detecting and asking owners for help. And because nobody knows where these are, over time, we've located, one under a shed, another under a paved over driveway. Having GPS coordinates would really make that process a lot easier rather than, unfortunately having all the information in someone's head. While we're on the subject of location, you can actually divide your assets into two sort of large groups based on how you track their location. The first one of these is field assets, sometimes called horizontal assets. These are typically point assets like wells and pipes and valves and meters, things that are out there in the field and that are going to have their own individual GPS coordinates, also typically because they're further apart. The other kind of assets are called plant assets or vertical assets. And these will often have the same coordinates assigned to them because they're located in the same place. So inside of a water treatment plant, if I'm doing an asset inventory, data collection process, I'll often just hang the GPS on the door and use the same coordinates for everything inside, because I can, once I found the building, I've essentially found everything inside it. Of course, there's a scale issue there. If it's a really large treatment facility, I would probably want to narrow that down, maybe do things building by building or floor by floor. Here's an opportunity to use the chat. Thinking about booster stations, how do you think those would best be tracked as field assets or plant assets? And you can go ahead and use the chat to type that in. Well, while you guys are thinking about that, yeah, plant, exactly. Once you found the building, you found everything in it. This happens to be a project that we did in American Samoa. And to make things easier, we essentially just tagged the building and then use those coordinates for everything inside it. You could try to do individual coordinates, but the other problem is that GPS looks at satellites, and if you're inside a building, sometimes that interferes with the reception. So yeah, plant. Third question, and this is really the biggest and most important question, is what do you need to know about your assets? And this is where the asset inventory really starts to become useful, because this is where all the details are. It's kind of like a recipe. If you leave out a critical spice, it doesn't taste right. If you leave out a critical piece of information in your inventory, that can have significant consequences with regard to the usefulness of your inventory and your ability to do analysis on the items that are in your inventory. One way to think about what data you should collect is to think about the kind of questions you want to answer about a specific asset. So let's talk about hydrants, for example. What kind of information might you want to include in an asset inventory about hydrants? Yeah, age, material type, exactly. Make, model, date, yeah, exactly. Those are the kinds of things that we're looking at. It's that sort of granular information. You might want to know its asset ID and name, obviously where it is, what kind of condition it is. Yeah, elevation could be useful because that's going to be important for pressure, remaining useful life, when it was installed, replacement cost, is it operational or not, pressure, whether it'll support fire flow. I've heard some horror stories about, size of connection valve, whether it's part of a flushing program, is it on a testing schedule, what's the color mean? There's all sorts of things that you could collect about this that would be useful. You don't necessarily have to collect all of this information, but you should be collecting and tracking information that's important to you. For this one, maybe who's got the keys to that lock would be important. And as we look at the list of things that I've put up here and the list of criteria that attendees have put in, you'll realize that there's sort of two sets of attributes. Some of them are very, very specific to hydrants, and others are much more general and would kind of apply to virtually any kind of asset. So I'm going to sort of walk through the most critical pieces of information so that you've got an idea of what we think is most important to be tracking. Obviously, everything should have a unique asset name and or ID. You want to keep them. Photos is also important. You've preempted me a little bit in the end of my presentation. We're actually going to do a demonstration of some data collection, and photos are really important because they're a great snapshot of at least the physical condition that you can see of an item in time. So yes, collecting photos is really important. With your assets, you want to make sure that they've got a unique ID so that you can differentiate them. And that's what this whole inventory thing is about. It's about tracking assets and being able to differentiate them. You really want to make sure that a specific asset ID stays with the specific asset. And if that asset gets replaced, the replacement gets a new asset ID. Now, obviously, you don't want to throw away the information that you've collected about the old asset that was replaced, because that's going to be useful for anticipating how things deteriorate. And so you want to archive that in some way, but you want to make sure that it's associated with the old asset. We do a lot of pipe break analysis for utilities, helping them try to decide what should be replaced and in what order. And we quite often see pipes that have been replaced within the last 5 years that have break data associated with them that goes back decades, because the new pipe basically had the same asset ID number as the old one. So then we have to go through and sort of segregate all that information. So if you give your replacement assets a new asset ID, you're going to be in much better shape, because you're going to be able to associate meaningful information with your new assets and not associate old outdated information with them. I said that asset IDs should be meaningful. There are a lot of different ways you can do asset IDs. I've seen places that just do straight up numerical. They start from 1 and work their way up. I like to do asset IDs that have initials with them that give me an idea about what I'm talking about. So, starting meters with M, valves, maybe with abbreviation that indicates the kind of valve it is, like GB for gate valve, BV for butterfly, and ARV for air relief valve. These are just examples. These are not the only ways you can do it. I've seen very complex setups where by looking at the ID, I can tell what it is, what part of town it is, and maybe which pressure zone it's in. But the idea here is that you can use your asset ID structure to hone in on information and to differentiate information. So you might only want to be able to look at valves in a specific part of the town. And if you've got a nomenclature structure that facilitates that, that'll make it a lot easier. Recognize that a lot of assets are related to each other in what's called a parent-child relationship. And a booster station is a really good example of that. So a booster pump might actually have, a pump, a motor, and a valve associated with it. And all of those things you may want to track separately because they wear at different rates and they may have different maintenance needs or ages. The pump may be good and you replace the motor, or vice versa. You might have a parent asset that's the booster and child assets that are the pump, the motor, and the valve, because sometimes when you're thinking about how you're dealing with them, you want to think about the thing as a whole, and sometimes you will want to look at the individual components. And making an asset ID system like this will facilitate that. These can get relatively complicated. The booster station might actually be the parent. The children might be the actual structure that everything is in, and the booster pump, and then maybe the grandchildren are the motor and the valve. There is, no real right or wrong way to do this. The important thing is that it makes sense to you, and that it helps facilitate the differentiation of assets, and that it helps you categorize them and assess them. Next thing you really want to track over time is condition. And this is one of the places that photos really come in handy, particularly for the assets that you can see. Obviously, photos are a little bit more difficult with the underground assets, but we'll get to those in a minute. Condition, defines the physical state of an asset at a moment in time. And that's something that's really going to help inform remaining useful life and your maintenance schedules and your intervention and your replacements. And you really want to be able to track this because most utilities, unless they're brand new, are going to have situations like this where you've got hydrants of different ages and that are in different conditions, pipe of different ages and different conditions, and you want to be able to track individually how things deteriorate over time, and you want to be able to assess that condition uniformly, so that if Bob goes out and does an assessment, he gets the same sort of assessment that Sally does when she goes out and assesses some other ones. So how do you do that? How do you evaluate condition? You develop a condition rating system for your assets. A 5-step scale is really a good starting point. You could do 1 to 3, or excuse me, 1 to 5. With 1 being in excellent condition and 5 being in poor condition. You could literally just use the words excellent, poor, good, average, fair. Theoretically, you could do it with emojis, although that wouldn't work very well in the database situation because the database isn't going to be able to read those. But you could maybe use a grading system like A through E. Although any of these work, the most important thing is actually not just coming up with a scale, but defining what the criteria are that mean something is excellent or good or average or fair or poor. And my personal preference is to actually use a numerical scale where excellent is 1 and 5 is poor. Depending on the size of your system, you might actually use a larger scale or a slightly smaller one. I wouldn't do anything under 3. And I say the numerical scale works best because you can use this for risk analysis and doing criticality checks and things like that. So you can sort of build the condition rating into a formula to help you look at condition scales. And as I said, the important thing is to define what that 1 means, what that 2 means. And you want to use objective criteria to make sure that assets that are in similar condition are graded similarly. If you don't provide those criteria, it causes a couple of problems. First, the staff is left to their own devices, which means everybody's basically making up their own definitions about what's good, what's fair, what's bad. And second, there is a tendency that we've seen to gravitate toward the middle with grading. Nobody really wants to be wrong. So if you don't provide actual criteria to associate with those grades, there's a tendency to sort of move toward the middle or move toward the top. And that's not really what you want to do. The whole purpose of this is to be able to differentiate individual assets. So we want to have those criteria so that everybody can apply that information correctly. What we'll typically do is start at one end of the scale and work that out and then figure out what the graduations in the middle are. So one example for a hydrant might be that, a hydrant with no visible leaks, it's got all the caps in place, there's no known internal problems, there's no visible rust or damage, only requires routine maintenance, and it's fully operational. Those might be the criteria that we use to define a 1 or an excellent. And then we go to the other end of the scale and say, okay, well, what's poor? Well, maybe visible leaks, missing caps, known internal problems, significant rust or damage, maybe it requires more frequent maintenance, or maybe it's completely non-operational. And by doing that, you've essentially defined criteria for the opposite ends of the scale, and then you can use those to define the conditions in between, the good, the average, the fair, the 2, the 3, the 4. Haley just pushed out a document that you can use as a reference. This is not the standard. This is just an example of condition ratings that you could use for hydrants. And the reason I've pushed this out to you is just that you have something as a reference. We're not going to go through this all right now, but if you're trying to develop condition scales for hydrants or any other assets, this is going to kind of give you some information to look at to sort of plot how you can sort of do that differentiation. I do want to note that obviously your criteria for other assets are going to be different, but within your utility, you should use the same numerical scale for everything. So if you've decided on a 1 to 5 scale, rate the condition of your valves on a 1 to 5 scale, your pipe on a 1 to 5 scale, your meters on a 1 to 5 scale, et cetera, because that'll keep things uniform. And that way, when you're looking at the whole of your assets and doing condition ratings, you can pick out the stuff that's in really bad shape, either by specific asset class or just across the board. With regard to condition rating, I do want to point out that there are kind of 2 different approaches that you can take. One I refer to as field grading, the other one I refer to as field assessment. And by field grading, what I mean is that the operators or your staff are in the field reviewing the criteria and actually assigning the grade at the same time for the asset that they're evaluating. The other option is to do field assessment. That works best if you've got some sort of a form. An electronic form is the best option, and I'll show you a version of that here in a couple of minutes. And what you can instead have people do is just answer the criteria questions, and then either have the tool that you're using assign the grade based on the conditions that you've assigned, or you could do the grade assignment back in the staff, back in the office. After the data has been pulled together. Either one of these is perfectly fine. to do. Which you prefer really kind of depends on your staff and how comfortable they are doing the actual assessment. Doing the assessment versus the grading kind of takes the onus off the person in the field of assigning that numerical value. They basically just answer the questions, are the caps missing? Is it functional? What % of the body's covered in rust? And then move on. So it can actually kind of speed things up in the data collection. And then it can also, again, take that onus of doing the grading off of the person who's out there in the field collecting the information. Another key piece of information to track in your inventory is the remaining useful life, because this is going to help you budget for capital improvement and maintenance, and recognize that age is an important factor, but it's not the only factor that's going to play into remaining useful life. There's going to be a lot of factors that impact that, including installation, its maintenance record in the past, what kind of elements it's in. Obviously, we're not going to cover all of the details to determine something's remaining useful life here, but just recognize that just because a PVC pipe typically lasts 50 or 60 years, there may be conditions where it only lasts 10 or 12, and we've actually run into that before. When you're thinking about sort of the lifespan of an asset, they're all going to follow something more or less like this, where they start hopefully in their best condition ever when they're first installed, and then over time they're going to deteriorate, and at some point they're going to reach what we call the minimum acceptable service level, which basically means once they've hit this point, they're just barely doing what you need them to do. And if you leave them in place any longer, they're going to either fail functionally or fail completely. What we want to be able to do is track conditions so that over time, when we're in this part of the curve where things are deteriorating more quickly, we can become cognizant of that, and then we can decide what kind of intervention can be done. It's not failed. You can do the intervention at a time of your planning. Planned intervention is almost always cheaper than reactive intervention. There's a lot less drama and cost associated with it. And again, part of the reason you want to track this information is because, like everything else, how pipe or valves or other equipment deteriorates in your particular situation can be very different than it does in someplace else. We've seen utilities where pipe on one side of town deteriorates at a much faster rate than the other side of town because it's got acidic soil and the metallic pipe just gets eaten up quicker. And that's the kind of thing that you want to be able to track and predict over time. So again, you can do that budgeting ahead of time, and you can do that planning. Obviously, a related piece of information is replacement cost. Going to be critical for future planning. This is not what you paid for the asset when you put it in, but what it's going to cost to replace with whatever model you're going to put in. So if you have old mechanical meters and you're going to replace them with the latest, iPearls, it's the cost of those iPearls plus installation. For replacement cost inventory tracking, you don't need to have this, down to the penny. And obviously, the further out you're thinking about doing a replacement, the less accurate you have to be. But a reasonable cost is really critical because it will allow you to sort of do that condition assessment, do that criticality assessment, and immediately have a cost associated with it, rather than sort of having to do that all separately. Really, really critical for future planning. Other important information that you might want to track, size of assets, but recognize that size means different things in different contexts. For a meter, it's going to be diameter. For a pipe, it might be diameter and length. If we're talking about tanks, it might be the volume and maybe even the area on the ground. For a motor, it might be horsepower. That kind of information is critical because when you're doing repairs, it's good to know what sort of equipment and what size replacements to bring out with you, but it's also going to play into that whole cost equation as well. Material is really, really important, particularly when it comes to pipe. If you're a relatively new system, you might be all brand new and PVC, but most systems, evolve over time, and they're made up of pipe that was, whatever was in vogue at the moment the installation happened. So, it's not unusual, obviously, to see systems that have cast iron and PVC and asbestos cement, and steel, and all sorts of stuff that has been put in over time. And all of those materials age at different rates. And as I said, they may age at different speeds based on where they are in the system, or maybe based on the pressure. Keeping track of the materials will help you keep track of how things are aging and help you extrapolate information across your system. Age is also important. Somebody mentioned that in the chat before. That's a really important thing, although it's not often isn't the best predictor of lifespan. It is really good to know when something was installed, so that when you're evaluating assets, you can extrapolate their condition from other similarly aged and placed assets. It's not the only factor, but it certainly is a factor. If well pumps in your system typically last 15 years, you're going to want to know when you're approaching that 15-year mark, so that you can think about replacing it, or at least maybe make plans to reassess its condition more often and keep closer track of the deterioration. And as I said, age is a factor. It's not the only one, although particularly in smaller systems, we see that becomes sort of the default factor for pipe replacement. We recently did a pipe break analysis on a system in the Midwest. They had pipe dating back to the 1930s, and it turns out that the actual worst pipe in their system was from the 1950s, followed by pipe from the 1970s, and then pipe from the 1930s. So just sort of keep that in mind. Age is a factor, but it's one of many. And although we're not really going to be talking about this today, keeping track of break data and event data is really, really critical, particularly when it comes to pipe, because the stuff is underground. It's hard to evaluate. It's expensive to evaluate, and knowing how things are breaking and taking pictures of breaks when you've got them uncovered and doing repairs is going to go a long way to help you determine what kind of condition your pipe is in. Those are obviously not a full list of information that you could collect, but those are things that we think you should collect. Operational status, manufacturer for recently purchased items, warranty status might be important. Think about supplier contacts and order lead times for critical assets. If you've got large pumps or motors, you can't just go down to the hardware store and buy a replacement. If you don't have a spare on the shelf, you really need to factor that lead time in, so that when you're thinking about replacing things, you can do that in an orderly and organized fashion. We do a lot of work out in the territories, Guam, Northern Mariana Islands, and Samoa, and if they don't have something on hand the moment they need it, it often takes months for it to get to them. So, as you're going through your inventory and analyzing it, think about the things that are not easy to replace, and maybe think about tracking lead time and supplier information for those. All of that information is useful, and all of that can go into an inventory. And by tracking that, you really can transform the inventory from a simple list, which is what we often see people start out with, into a list that has the details that you can actually use for analysis and decision making. I think those preceding slides give you sort of a good overview of the basic asset information that should be included in your inventory, and that will help you sort of maintain that current understanding of your assets. But the exact inventory details are obviously going to be up to you and should be based on your needs. And what's important to you, because obviously tracking this stuff does take time and does take some effort. So you want to be efficient and thoughtful about it. When you're thinking about what to put in your inventory and where to get information, start with existing sources. If you don't have one already, you probably have as-built or some sorts of maps. The map on the left here happens to be a sewer as-built, but you can see there's a ton of useful data right on the page there. The manuals actually already have names. So if you were thinking about a naming convention, well, there's one laid out for you right there. It tells me, how big the pipe is, where it is, what the flow directions are, all sorts of useful information. Picture on the right is the nameplate from a tank. You can see it's got, height, volume, serial number, who manufactured it. I've seen others that actually have the dates installed. I've seen systems that have a plate on the side where they track when the tank was refurbished. Similar equipment like motors and pumps have a lot of data stamped right on them. So, you know, the actual assets are often great sources of detailed information. When you're thinking about how to develop your inventory, think about who's actually going to use it. Is it just going to be your operational staff, or do maybe finance people need to look at this as well, and for collaboration in terms of, you know, capital improvement planning? Think about how the asset data is managed for your system. You know, is the water utility the only group that's going to look at this data? And if not, think about what information might be useful to the other departments who may have some visibility, even if they're not sort of looking at it on a day-to-day basis. You know, what kind of information can you collect that would help your organization as a whole, and maybe not just your individual department? Think about the records that you have. You know, you could have call logs, you could have pictures that people have taken of different events. There may be video, there may be notes. You know, we often see people handwriting notes into map books. All of that stuff is useful. Those are all useful ways of collecting information. And the important thing here is that, you know, whatever information exists, get brought together and organized in a systematic way. And you can start small. You know, you don't have to devote a ton of time to this all in one fell swoop. You can start with important things or more critical assets and work your way into the process. Who's going to push out another document here that is a reference guide. This is particular one happens to be for drinking water systems, and it doesn't include every asset that you're going to have, but it has most of the critical ones. And it's got a list of information that we feel is necessary to have in an inventory, some thoughts on optional data that you might want to collect, and then thoughts about where you could actually find that information. So I think this will be a very useful resource for you if you're developing an inventory from scratch, or if you're trying to evaluate your existing inventory and want to see whether you could improve it or not. Obviously, if you're building an inventory, you have to think about where you're going to store that information. There are a ton of different ways to do that. You can use a CMMS, you know, computerized maintenance management system. You can use GIS, which we'll be talking about in the second half today. You can use Excel, you can use paper. I've seen a utility keep their inventory in a recipe box because they were very, very small, and that was an efficient way for them to do it. Not so good for the analysis piece, but it is functional. If you're currently doing your inventory on paper, or you don't have an inventory and you're wanting an easy way to start, I think Excel is a great option as a starting point. Our website address is right there. We'll send out a link to this particular tool in our follow-up email as well. But this is an Excel spreadsheet that we've put together that has essentially fields for all of the things that we've talked about, plus more. There's some energy information on here that's also useful. And the nice thing about converting to this sort of format is that it's digital and it can grow with you. Fundamentally, you know, anything in a computer is ones and zeros, and data can be reformatted over time. So if you start out with an Excel sheet and you want to move on, yeah, you can keep stuff on napkins. If you you know, start off and you know, on paper, you can move to Excel, and then maybe you decide, oh, we're going to move to some sort of in-house small database. Data can be transformed, and the information can grow with you, so that you don't lose that that critical information over time. Again, quick plug for the asset management switchboard. That tool I just showed you is on there. There are a lot of other tools on there as well. When you're thinking about your inventory, keep in mind to make it as complete as possible, but you don't have to inventory the pencils and pens in the office. You know, keep it reasonable. A lot of systems will use maybe $500 or $1,000 as a cutoff for items that they're going to inventory. Prioritize your most important data. If you're starting from scratch, you know, it's often easy to start with the things that you can see. Maybe start with meters, because those are your cash registers. And we often find that systems who think they know where all the meters are find out that they don't. So Start with the most important thing. And an inventory is only as good as it is current. We typically will say you should review your inventory about once a year. Doesn't have to be an in-depth review, but you should look it over. And obviously fix errors as they are found. Nothing is going to be perfect, particularly when you start out. You're probably going to be pulling information from a variety of different sources, and there's going to be inconsistencies. That's okay. Something is better than nothing, and you can fix as you go. You may find your inventory says a pipe is 6 inches in diameter, and the next time you do a repair, you realize it's 8. No big deal. Just update the inventory to reflect the new information. Make sure that the data you collect is consistent. The number 2 and 2 inches are not the same thing to a database. And this is also the kind of cleanup that we often have to do when we're helping systems out, because as people have changed jobs and new people have collected information, the standards have changed. So sorting the data becomes more and more difficult over time. So when you're thinking about how you're going to collect this data, make sure that you set up things to be done consistently. Determine which fields are going to be mandatory and which fields are going to be optional. On the subject of pictures, which was brought up earlier, I tend to think of pictures as mandatory for anything that I can see, because I want to be able to see that snapshot, because a lot of times that's the only thing that you've got to rely on. You don't want to rely on somebody's memory about what a hydrant looked like 5 years ago. If you've got a picture, you've got all the information you need. And keep data keys. Often, particularly in databases, but even in spreadsheets, you're going to use abbreviations. Make sure you maintain a list of what those things mean. We did work with a utility a year or two ago that had a couple of decades worth of brake data, and they had 30 different codes for different kinds of brakes, but they'd lost the definitions for the codes. So what could have been a really robust analysis was significantly hampered by the fact that we didn't know what any of these codes meant, and we could only essentially know that a break had happened and where it had happened. And again, when you're thinking about what needs to go in there, make sure it's got enough to support your analysis and your data decision making. So quick review, at a minimum, asset names and IDs, location, condition, remaining useful life, and replacement cost should be in your inventory. From there on, it's really kind of up to you: size, volume, age, material. Other things that we talked about and other things that people put in are also useful, but you don't want to get in the process of collecting data just for the sake of collecting data. You want to collect data that's useful. Recognize that developing an inventory is about process. You'll see I like these round graphics. Before you start doing it, plan. Think about what data you want to collect, what tools you need, what software you need, what kind of a time frame you're working in, who's going to use the data. Then go out and collect that information, combine the sources, pull together useful stuff, proof it, obviously, because there are going to be conflicts, and you want to screen as many of those as you can, and then use it for analysis. If you build an inventory and don't use it, you've wasted a bunch of time. An inventory is a living document, and it should be used over time. So spend a lot of time talking about what should go in it. Let's shift gears a little bit and talk about different ways of collecting that data. Now, obviously, if you have survey grade equipment, that's great. You can use that, and you'll get pinpoint accuracy on all of your assets. But fully integrated survey grade equipment is very expensive. What we're looking at here is a Trimble device with all the bells and whistles. You might be looking at anywhere from 20 to 40 grand, and a lot of small systems just can't afford that. The good thing is you don't actually need that to do the kind of work that we're talking about here. You don't really need centimeter resolution. You just need to be able to find things. One of the options that we use personally at the EFC is a combination of an iPad, although an Android device will work just as well, a GPS receiver, a GNSS receiver, and a piece of software called Fulcrum. And this is not the only piece of software like this. It's just one that we happen to use. ArcGIS has Collector. There's a bunch of free different versions out there. For example, there's a program called QField that does the same thing. It's an open source free project that you could use. But these kind of tools, which I'm going to show you a demonstration of here in a second, can really make that data collection and that data tracking much easier for you. On the planning side of things, again, before you go out and buy equipment or before you decide what you're going to use, think about what your needs are, what your capabilities are, and what sort of technical expertise you are willing to develop in-house. On the left-hand side here, we've got 4 of the many different kind of data collection apps that are out there. Collector for ArcGIS, Survey 123, Fulcrum, GPS Fields Area Measure, and across the top, you can see some different functionality. Some of them will work on Windows phones, Android, and iOS. Some only work on Android and iOS. Some have online functionality, some don't. So think about what kind of functionality you need and what you're going to use it for before you dive in. And obviously, if you've got questions about these things, feel free to reach out. Haley told you about the free technical assistance. We love to geek out on this stuff and would be happy to talk to you about it. But I think the best way to kind of get an idea about how to use one of these programs is to show you a little demonstration. So I've put together a little short movie that demonstrates the back end and the front end of one of these pieces of software. This happens to be Fulcrum. We're not saying this is better than any other one. It's just one that we happen to use. Most of them work in a very similar fashion. But I think this would be useful to look at, particularly for those systems who don't really have internal data collection capabilities. I think a lot of times sort of setting this sort of thing up seems a bit daunting, and it's really not. There's a really sort of shallow learning curve, and this is, again, a really inexpensive way of doing it. This is the kind of thing that you could probably get up and running for less than $1,000, and then all you would have to do is pay, a monthly fee, for example, for access to Fulcrum, which I think is about 25 or 30 bucks. So it's a very affordable version. If you use QField, you could essentially do all of this for free. So I'm going to show you a quick video here that kind of walks through the process of building a data collection app and collecting the data with it. And we're going to take a short break, and then we'll talk a little bit about mapping the information that we've collected.
This is a short video about field data collection. In this case, we're using an iPad running Fulcrum's software and a Bad Elf GNSS receiver. By pairing a GPS or GNSS receiver with your iOS or Android mobile device, you can take advantage of the GPS accuracy of the receiver and the data collection capabilities of your mobile device. Fulcrum has a web interface that you can use to build data collection applications and also to review and edit your data. We'll start by looking at the web interface of a simple hydrant data collection application, and then we'll use that same application to do some field data collection. So what we're looking at here is the designer portion of Fulcrum's web interface for the app that I've built for hydrant data collection. What you see on the left-hand side are the basic kinds of fields that you can use, and on the right-hand side you can see the configured app that I've already created under layout. Each of these different fields are essentially drag and drop. As you'll see here, I'm going to add in a date field, which simply involves me grabbing the date field from the left, dragging it to the location in the application that I want it to be in, and then configuring it with a label and a description. You'll notice there are a variety of different kinds of fields that are available: text, numeric, yes, no, dates, single and multiple choice fields that will do calculations. You can also use the design fields to organize your application. You'll notice I have several sections here, one for field data, one for general data, and so on. By clicking on the pre-configured fields that you've created, you can edit them and verify that the information you're using is correct. So for here, for example, I've got hydrant size with a couple of different size options. I noticed I didn't put in a description for serial number, so I'm going back and filling that in. Under type, I've got 3 options. I'm making this a required field because I want to make sure that data gets collected in the field. You can also preview an application that you've built via the web interface by clicking on the Preview App button. That will show you the basic layout that a mobile user will see in terms of the order that fields are going to be listed in and whether they will be visible or not. For example, you could create an application and hide the office data because that won't be actually used in the field. Obviously, anytime you make changes to your applications, do not forget to save. So let's use this app to go actually collect some data. So I've got my GNSS receiver here, which I've placed on top of the hydrant. And what you're seeing now is a screen capture of the data collection process from the iPad itself. So I'm picking a hydrant type, I'm picking a manufacturer off a pre-configured list. Same goes with the size. In this case, my hydrant does not have a serial number. I'm skipping that. It does have an isolation valve. It's a single color. You notice those red asterisks indicate that the fields are mandatory. Pictures are very, very important. Always take those. In this case, I've actually taken a picture of the GNSS receiver as well. Before I save the record, I check my location. One of the nice things you can do with this is actually modify the place of your record using the base map. There's actually an Android interface for this I mentioned. This is essentially the same data collection application, but you'll see that the layout of the interface is slightly different because of the different operating systems. That being said, the list of information is exactly the same. It's just laid out a little bit differently. So once you sync your data with the cloud from your mobile device, all of that information that you collected will be available on the web interface, and anything that's been added to the web interface since the last time you synced will now be available on your mobile device. So we're going to view some of the records that we've collected. These little pink dots represent hydrants that we've collected in and around the UNM campus area. I have a couple of options in terms of how to look at them. I can look at just the data. I can look at a combination of the data and the map. I can also filter each of these various conditions. So for example, if I just want to see my Mueller hydrants, I can click on that and it will reduce the list of those. And if I go back to my map and look at them, the only thing that will be shown are the Mueller hydrants. You'll notice I have a somewhat busy base map back here. I'm going to change that for ease of use to a simple street map, kind of like a Google map, which clears away some of the clutter and makes the points a little bit more visible. So you can see a few of them scattered around. I'm looking at records that are in this field. There are about 31 total. It's showing me the records below that it can see in the map. So if I zoom out on my map, you'll see the records below get populated to reference everything that's currently in the visual frame of the map. I can do a quick view of the data related to any record, which will essentially give me a short form layout with all of the information. I can also click on the picture and it will bring me to a more detailed picture relating to the image itself, which not only shows me the picture, but where I took it and some metadata about the image. Now, obviously, once the information's up there, I'll probably want to download that. I've got a lot of options, CSV, Excel, Esri shape files. I can download either the filtered or the unfiltered data from here. I can also download this information from the main app page where we started out by simply going to the exporter. The advantage I have here is that I can download multiple files from a lot of different apps that I have created.
All right, so hopefully that kind of gives you a flavor for how these things work and makes it maybe a little less intimidating. One of the things that I didn't discuss in there is the fact that you can actually push data up to these kinds of applications as well. So quite often, we'll start with if we're trying to do a meter inventory, we'll push inventory information out of the billing system, put it into Fulcrum, and then go out in the field and collect additional data and then push the information back in. So the information can be pushed both ways. So the last thing I want to talk about on this sort of section before we take a short break is that, when you're thinking about building an inventory or maintaining an inventory, right size it for your particular circumstances. You don't want the data collection process to be a burden. You don't need to overcomplicate it, but you should be tracking assets and data attributes that are useful to you, and start with those critical assets. This is the kind of process with a little bit of effort you can kind of build into the everyday processes that you do, and collecting this kind of information is gonna make your life a lot easier when you're sort of further down the road and are trying to do capital improvement plans and are trying to decide, what needs to be touched when and how to prioritize things. So I'm going to open the floor up for quick questions, if there are any now, and then we'll take a 5-minute break, and then we'll come back and talk about the mapping side of things. And I do realize we've run a little bit long on this section, but we'll be sure to catch up. The next section is actually a little bit shorter, so we should be able to end exactly on time. So Haley, are there any questions so far?
No specific questions. So I think we're good to take a break. I do just want to let everyone know that along with the slides that I'll send out in a follow-up email, we'll also have a link to an evaluation, which we'd love for you to fill out if you have the time. It's not too long, but we always like getting feedback.
So we're going to shift gears here a little bit. And talk a little bit about mapping. And you may have noticed that I've used a variation of the asset icon here for this section, and that I use the same tagline: supporting operational analysis and data-driven or data-informed decision-making. And the reason for that is that they both fit here as well. I really think that maps are a useful extension of and supplement to the inventory. I think they're an integral part of it, and that they too can and should be used for that operational analysis and data-informed decision-making. What we're going to talk about in this section is some basics about GIS, the value and utility of mapping your assets, available mapping resources, functions of various GIS platforms, which GIS platform might be right for you, even as a small system, and how to get started mapping your assets. And I know for a lot of systems, particularly smaller ones, the world of GIS can seem quite daunting, both in terms of expense and technical expertise. And obviously, we're not going to spend today trying to teach you actually how to build a GIS map or use one, but we will show you how it can be done. And hopefully, this presentation will show you some options that aren't as daunting, at least in terms of the expense side of things. And hopefully we'll show that this is something that is actually really within your reach. So starting off with, what is GIS? Well, GIS stands for Graphical Information System. GIS is a system for storing and communicating and working with geographic information. It can be really complex or very simple. And technically speaking, as somebody pointed out before, you could use a napkin. A map on the back of a napkin technically is a GIS because it systematically communicates geographic information. But in this context today, we're going to be looking at GIS as a way of producing water system asset maps and working with and analyzing utility data. And I really love doing this kind of stuff because, maps can really tell you so much more than just what something is and where it is. If you've got good records, if you have good information that you've collected for the inventory itself, you can pull that stuff into your maps, and you can figure out, who did something, maybe which contractor made repairs, or when something happened, why it was done, how something happened. So, event data, for example, tracking breaks I mentioned earlier is really important. If you track, breaks and include, why the break happened, was it a split, was it corrosion, that can tell you really useful information. And again, if you've been collecting that replacement data that I talked about, the replacement cost data, you can use GIS maps to actually give you pretty good cost estimates on different kinds of projects. The big thing here is that maps show you patterns. and identifying patterns in your data can really save utilities a lot of money and allow you to develop, much more efficient capital improvement and replacement plans. And, the beauty of a map is that you can see patterns in a map that you just would not see in any other format. So obviously maps come in a variety of formats. This is an example of a paper map book for a system that we were working with recently. They had a copy in the truck and in the office and copies in operator trucks. And you can see that there's handwritten notes there. And if you're working with paper maps, updating things like this is a great way of updating information. The drawback to this approach is that every operator is going to have a slightly different set of notes. You may not necessarily have consistency across various maps. So the takeaway here is, regardless of what sort of mapping system you're using, whether it's paper or digital GIS, it's a really good practice to periodically consolidate updates and new information and look for those inconsistencies, so that your maps remain uniform and up to date. Just like the inventory, the more up to date it is, the more useful it's going to be. If you have paper maps and you're interested in moving into a digital GIS system, those paper maps are an incredibly useful source of information for getting started and can be incorporated directly into the digital GIS. This is quite often the starting point that we use for mapping projects. Here you can see the exact same paper map after it's been brought into a digital GIS. I'll show you this sort of process here in a little bit, but you can see those handwritten notes are all visible, as well as the digitized blue water lines that we've laid on top of that. We did something called geocoding, but essentially we basically combined those paper maps and some CAD files that we got from the utility and created a utility-specific geometric network for both their water and their wastewater side of things. We basically digitized those paper zone atlas map books and then took all of those notes and pushed them into the database. And we also left the actual map images visible as semi-transparent layers as reference points, so that when there were conflicts, we could work through them. And it was also kind of a useful way to help folks who were used to the paper maps transition into the digital world. Here's some additional asset data that also went in to that set of digital maps. This happens to be sewer leak call log data. And you can see that there's actually quite a lot of useful information on here. We've got timestamps and dates and addresses and some notes about what kind of problems there were. We actually had information that tied it to their work order system, so we could go into there and pull details. And so when we built that system map, we did the assets, and then we used information like this to pull in condition information. So where the breaks had happened, where there were problematic, system clogs and things like that. And we were able to use that information to sort of build out condition data for assets that we couldn't actually see because they're all underground. This is great information, but again, you can't visualize it until you put it into some sort of mapping system. The data becomes really, really useful when it's incorporated into a digital GIS. And this is a full-blown water and wastewater system with all the bells and whistles on it. On the left-hand side over here, you can see all the different layers that we have. Each layer is stored as a separate file on the computer, and you can turn them on and off by clicking on these checkboxes. We call them layers because that's essentially the way they are. The map gets built by stacking the different layers on top of each other, and you display what you want to see. The table in the middle is an attribute table, which you might notice looks an awful lot like an inventory. And yes, you can actually use the GIS system as your inventory, and we highly recommend doing that, or using it in conjunction with a CMMS system if you have that capability. The nice thing about this is you can see up here, I've got this segment highlighted on the map. That's this segment right here with all of the information that's been collected about it. That attribute table has every attribute that's ever been collected for that asset in a given layer. You can select assets in the map, highlight them. You can select assets in the table and highlight them in the map. And you can see all of the data that's collected, for this particular pipe segment. We've got a facility ID, which is essentially an asset ID. We've got material and diameter and water pipe and install date and who owns and manages it, when it was last edited, its geometric length. And then if we were to scroll off to the right, there's a whole bunch of other information there. And the nice thing about a GIS is it's essentially a database. So any asset information you want to collect, you can add in here and have at your fingertips to use and manipulate. And having a complete list like this is, really useful for making evaluation of your system, for example, down the road, or if you really want to quickly determine like how much 4-inch PVC pipe do I have in my system, because that's something that's giving me problems and I need to address it. Well, with a system like this, you can do a very simple query and say, show me all the pipe that's 4 inches in diameter and made out of PVC, run that query, and it pulls up all that information. You can export that information in a variety of formats. You can see all of that. You can do the same sort of very complicated queries, where you could look at, cast iron pipe that's more than X years old that has this many breaks, and really sort of dig down into your information. The nice thing about this stuff is, although you can hide things, the information isn't erased just because it's hidden from view temporarily. I'll show you what I mean here. So this is, again, a close-up shot of the combined water and wastewater system, but we can choose which layers we want to look at by turning them on and off. Here we've got the sewer system turned off, and you can see the meters, the curb stops, the corp stops, the connections, the mains, with their asset ID numbers and some information displayed here. If we had event data, we could lay that right on top of it. Here's the flip side. This is the entire sewer system, and turning these on and off and visualizing them is literally the matter of clicking a button. But it's not just useful for sort of showing where things are and what you know about them. You can actually include, photos and video in this kind of a setup, so that you have sort of permanent records. And depending on what kind of system you use, for example, the Fulcrum system I was showing you earlier, you can use that to collect video data, but you can also use that to have video data available to folks out in the field. This tank here happens to be up in Alaska. The operator that's standing there off on the right helped build that when he was a teenager about 40 years ago. And I'm not going to play this video, but this is a video that we captured that's in their current GIS system that gives the details about this particular tank. And one critical detail, which is that despite the fact that this tank is 18 feet high, you can now only fill it to 16 feet, because a few years ago, a tank got built at a slightly lower elevation. Somebody did the math wrong. And if you fill this tank to 18 feet, it overflows at the other one and it's out of line of sight. So you won't actually see it happening. And that's the kind of information you really don't want your new crew members to learn the hard way. And that's also the kind of information that is really important, that you want to sort of keep as institutional knowledge. And, one of the attendees mentioned, looking forward to mapping their system. One of the best ways to get information about a system from operators is to walk around with them and, get to an asset, turn on the video camera and say, tell me about this thing. And, it's a great way of collecting information. We've done that many times here in the Southwest with small systems, and it's been a way to sort of download that institutional knowledge that an operator who's maybe been at the utility for 20, 30, 40 years has in their head in a very simple way. And it sort of lets you sort of maintain that legacy. Because when you think about it, all those water systems were probably here when you started working, and it's going to be here long after. So it's a great way to capture that information. I want to give you a couple of brief examples of the kinds of analysis that you can do with GIS to kind of sort of whet your appetite a little bit, and kind of show you, how you can go from, not having anything to having quite a lot. This is actually a fairly large city out in the Midwest, and they had distribution pipe aging from 75 to 100 years old. They knew they had to replace a lot of pipe. They had no way of prioritizing that replacement, and they didn't have any GIS data for water pipe. And so they couldn't really visualize the break data that they had. What they had was paper as-built scans like the one on the left, and and then a database, a work order database that had a lot of break data information in it. So what we were able to do is essentially digitize that. The picture on the left is sort of a cleaned up version from Photoshop, which we then pulled into GIS and built this out of. So when we were sort of doing this pilot project, we had them identify a part of town that, where the conventional wisdom basically said this is problematic, and we focused on mapping that piece. And what we did is we created the network, which is the blue pipes you can see there, and the red and the orange as well. But then we took the event data, that break data, geocoded that and laid it on top, did a query to figure out which pipes had the most breaks. And what you can see here is that there are some very problematic sections, and there are many sections, despite the fact that they're almost 100 years old, that don't have any problems at all. So if we zoom in here on the problem section, we can see that, I've got one segment here that has 23 breaks over the last, 5 or 6 years. And then we've got some problems going on down here. Now, obviously the map doesn't tell me why those problems are happening, but visualizing this, I can tell where the problems are, and it gives me a focus for my investigations. Maybe it's soil conditions, maybe that piece that's down by the water is waterlogged, and there's corrosion issues there that aren't present in other parts of town. I've seen situations where the pipe that got installed on a Friday is the problematic stuff because people weren't paying attention. So, what this allows you to do is visualize patterns. So we can see here that, most of the pipe in this area that was generally thought of as very bad is actually in great shape. Some have had, maybe only one break in the last 15 or 20 years. And if you want to, make a quick impact, you could do some very specific focused pipe replacement and knock your break rates and your water loss and everything else associated with that down fairly considerably. The other nice thing about GIS is you can track things over time. So this is one of those specific blocks. It's Ferndale Avenue. And when we were looking at the break data, we realized that in the early 2000s, there was about one break every 2 years. And by 2016, there were about 3 breaks a year on this segment. So again, we were able to see not only is this a break prone area, but the frequency of breaks is increasing. So this is, obviously a focus for replacement. Targeting these couple of areas could dramatically reduce the overall number of breaks for the system at the lowest cost, because they'd be doing it in a planned basis with the least service interruption. And then obviously, shutting down those breaks and replacing this problematic pipe is going to reduce water loss. And it's going to allow you to pinpoint scarce resources, because their original plan had been to kind of start at the west end and move to the east end and replace everything in this section. And although everything is going to have to be replaced at some point, it doesn't have to be done now. This is the other really problematic section in there. There's 23 breaks in 14 years. Most of those are localized up in the upper hand corner. And further development of this map, maybe adding cost per mile information in the database, would help more easily facilitate that sort of robust and targeted capital improvement plan. And it maybe, ideally you'd replace this entire section, but if you didn't have enough money to do that, well, you can tell from this, I need to focus on that northeast corner. And if I attack that, I'll probably knock my number of breaks down significantly. Point I'm trying to make here is that, there's going to be a lot of times when you're going to leverage data to make maps, but there's going to be other times, when you can actually leverage those maps and develop data. It's really a two-way street. Another similar example we did was a risk assessment for a sewer system. One of the factors that they identified as being relevant to the overall risk for pipe was the depth of bury. And that was actually a piece of data that they did not have. And this was an instance where we were able to sort of leverage the information that they had and develop new data. And so what we had was information about their manholes, which obviously intersect their sewer pipe. And we were able to use a definitional query and the manhole information to select pipe or manholes that were in the appropriate depth range, and then look at the pipe that is connected to those, and sort of basically back our way into figuring out which pipe was in that critical depth of bury that they were focusing on. And we were able to use that to make a map like this. And you can see, in this case, we did a risk analysis where things were scored on a risk of 1 being virtually no risk to 10 being really high. And you can see that they were able to pinpoint some very critical segments. There were other scores that were in the 7-8 range, but this showed very quickly the problematic pipe in the system. And we basically used existing map data to develop new data. And that would have been really, really hard to do outside of a GIS system. I mean, I guess theoretically it would have been possible, but what within a matter of days probably would have taken months. This is another example. This is out in the Pacific. We were working with a water system that has 60% water loss. It's the leakiest water system I've ever seen. And they had been using GPS to capture the locations of pipe break data, of pipe breaks, and in order to try and figure out what they were going to do. They were also hindered by the fact that they had an incomplete distribution system map. The map that they had was based off of a bunch of CAD files that had been brought in to a GIS system. It wasn't all that well done, and there was an undetermined amount of pipe that hadn't been mapped. And so what we were able to do is use the information from the GPSing of breaks to fine tune their map, and also do some estimates regarding how much pipe might actually be missing. So we did a query where we essentially said, okay, take every break and snap it to the pipe that's closest to it within X number of feet. And you can see that a lot of these breaks right now are well away from a piece of pipe. So we did that, and we got a slightly different map, and we're able to do a similar analysis to the one I showed you before to figure out which pipes had the most breaks. But you'll also notice that there are still pipe segments that are just floating out, or excuse me, breaks floating out where there is no mapped pipe. And we were able to run another query to sort of figure out the straight line distance from those types of breaks to the nearest pipe to get a rough idea of how much was missing. It's not going to be a perfect number, but they know more now than they did before. And this is information, again, that would not have been easily collectible without using a GIS system and GIS analysis. This is the map of the entire island. You can see water lines and leaks and breaks. And again, we did that sort of analysis, the criticality analysis. In this case, we did sort of a hotspot type analysis, and we're able to sort of rank the problematic pipe and give them an area to focus on. Because again, I said they had 60% water loss. It's really significant. They're out in the middle of nowhere, in the middle of the Pacific, and there's not a lot of funds available to address this problem. In reality, the ideal thing would be to replace the entire system. Practically, that's not doable. So the goal here was to focus on the most problematic parts of the system, and using GIS really helped us do that. So it's just a couple of examples of the kinds of analysis that you can do and sort of the kinds of data that you can develop with a GIS system and using sort of spatial analysis techniques. GIS, as I mentioned before, is very daunting to a lot of folks who don't have any experience with it. There are a lot of different platforms that you can use. I'm going to kind of run you through a few different options here. And again, not going to try and show you exactly how they all work, but to give you some basic background. You've probably heard of ArcGIS, ArcMap, or ArcPro. Those are products from Esri, Environmental Systems Research Institute, and they're kind of the industry leader for paid mapping products. The two main mapping products they have are ArcMap and ArcGIS Pro, and you can create and publish highly detailed and custom maps, and also give you the ability to view and edit and analyze spatial data. If you were going to go down this road, we'd recommend that you go with ArcPro versus ArcMap, not because it's any better, but simply because Esri is planning on phasing ArcMap out and continuing their development on ArcGIS Pro. Some downsides: these products are designed for the Windows operating system, so they don't run natively on a Mac, although you can do it using a program like Parallels or Boot Camp. I actually do run ArcGIS on a Macintosh, but it's faster if you can run it directly on Windows. And it's quite expensive. The licensing costs for ArcGIS are very expensive. The plus side is that they've got sort of an integrated system of applications for collecting data and for analyzing data, and they have tons of training and paid courses that will teach you about GIS applications and concepts and methods. But again, it can cost thousands of dollars a year, depending on the kind of license that you have. And of the options that I'm going to talk about today, it's going to be the most expensive. There's obviously a lot more information that can be found about Esri software and services at esri.com. But particularly for a utility that's part of a municipality or part of a tribal organization, check with your parent to see whether they may already have access. We've worked with some tribal water systems where the tribe has access to GIS because they use it for tracking other information and tracking cultural and historical sites. A lot of cities will use ArcGIS for certain kinds of activities. So if you can leverage something that you already have, you're in a great position. There's a free alternative, which is called QGIS. And it's a free open source alternative that's basically run by a large network of volunteer developers that regularly update and improve the software. It runs on virtually every operating system out there: Windows, Mac, Linux, Android. And like the Esri products, it allows you to create custom maps, manipulate spatial data, do a wide variety of analysis. Most of the things that you can do in ArcGIS, you can do in QGIS. They do have something of a steep learning curve, but there is a wealth of information and tutorials out there that can help you get started. I've spoken with many people who basically used YouTube videos to teach them how to get the basics done and have built functioning systems, and that's also something that we can help with. GISlounge.com is a great source for tutorials. And as I mentioned in the earlier part of the program, QGIS has a data collection app called QField that is integrated with it. So if you're thinking about wanting to get in the GIS world over time and you don't have a large budget, but you're willing to sort of take the plunge and develop the technical expertise, QGIS is a great way to go. And despite the fact that it's free, it is not a bare bones kind of product. There are entire national governments that use QGIS. The 911 system out here uses QGIS to map rural areas to make sure that the aid cars can get to locations correctly. It's a really robust platform and it's free. So it's a good way to get going. There's other mapping options that you could use. Google Earth's a free option. It's available in a wide variety of operating platforms, web browsers, iOS, Android, Mac, Linux. Unlike the GIS products that I talked about earlier, it basically doesn't allow you to view or edit the attribute data in the same way, but it's really good for visualizing mapped assets. So you can map your assets and know where things are. So this kind of map can be useful if you're like out in the field and need to locate things. Easy to use, fantastic option for getting started with maps if you're not really interested in doing that data analysis piece. If you're a small system and you just want to, get a hard record of GPS coordinates for where everything is, this might be a good option. There's another Google option called Google My Maps, which works similar to Google Earth, but runs in a web browser, has a few more options for sharing maps that you create, which is nice. But again, it does have some limitations in terms of how you can interact with a map and what sort of analysis you can do. Like I talked about with the data collection and the inventory, this is one of those things where you really want to plan ahead and think about what your needs are, what your capabilities are, and what sort of commitment you're going to make to be willing to sort of develop skills. Think about whether you need to produce and share maps, whether you want to do data analysis, do you have a budget for this or not? But also think outside the box. I have worked with some small systems where they brought in, summer interns from the local college and had them do some of the mapping process. We actually here at UNM a couple of years ago did a project with the state of New Mexico where we took geography students and engineering students, taught them how to use GPS and GIS, and had them go out and map systems. And so, there are a lot of different ways to skin a cat, as they say. So, again, if you're thinking about going down this route and you have some questions, we'd be happy to talk about it with you. Like the inventory, when you're going down the mapping project hole, start with the resources you have. You might notice the image on the right's the exact same one that I showed you before. Your existing paper maps are a great place to start. And I'll sort of step you through the process we use to turn those into digital maps here in just a second. But they, are typically available, even though they might not be the most current thing. But they're a great starting point. They've got a ton of information. And when we're doing mapping projects, particularly when we're looking at buried pipe, we don't have the equipment or the time to actually do ground penetrating radar and things like that, but you can get most of what you need, particularly from an asset management standpoint, off of paper maps. And to do that, we do a project called georeferencing. And that's essentially taking the paper map that has the map details on it, the pipe details on it, and other details, and associating it with map points that are in physical space. And so we'll basically start with a scanned map like this. We'll make it semi-transparent, and then we'll stretch it and pin things that we can see in the map. So maybe intersections or buildings to things that we can see on the satellite image that we're looking at. And then we can, once we've got that done, we can proceed to trace over the various assets that are shown in the map and add in those details and create an entire system map. This is a system up in northern New Mexico, and you can see that this is built out of their entire as-built map book. Some of the pages were small, some of them were big. What you're looking at here right now is just the mains, but if we were to zoom in, you'd actually see all of the meters and all of the connections as well. And we did a real combination of sort of this technique for assets that we couldn't see, the pipes and mains, and then we went out and did field data collection for the assets that were shown in the maps, and also to supplement that with assets that had not been shown in the maps. And then once we had that field data collection, we were actually able to fine tune some of the pipe information, because if we're looking at a water system and the valve is 10 feet to the right, well, we know the pipe is 10 feet to the right as well, and we can adjust. Field data collection is really critical, even if you're starting with a paper map. This is, again, a Fulcrum example, which is that program I showed you earlier on, but other data collection apps will look fairly similar. The field data collection is going to be the most important resource for your mapping, because in many cases, it might be the only source of asset and locational information, at least to pinpoint. And again, you can use field data collection to supplement maps that have been geo-referenced. And typically you'll end up with a combination of both of those kinds of things. So again, my purpose here was to sort of demystify some of this a little bit and maybe show you that it's not quite so difficult. And I think the best way to do that is to show a brief demonstration of pulling information out of, for example, Fulcrum or something like that, and putting it into a map. I told you Luke was going to be with us here in a virtual way. He put together a short video that shows mapping process in ArcMap and Google My Maps using the same sort of data. So I'm going to run this. And again, we don't expect you to be able to build a map after this, but it should give you an idea for how long the process takes and how difficult or not so difficult it actually is.
We start with the ArcMap program opened to a new blank map. Using the Add Data button in the upper left, we can bring our shapefile into the map by clicking Add Data and browsing to the file location of the shapefile. Select the shapefile, click Add, and we can see the points we mapped for hydrants drawn in the map view. We can see the data layer we just added listed in the table of contents on the left. By right-clicking this layer and selecting Open Attribute Table, we can see the attribute data that we collected in association with each point. Now let's give these hydrants some context by adding a base map. We can do this by clicking the Add Data button and this time selecting Add Base Map. There are a number of different base maps to choose from. Note that the use of these base maps requires an active internet connection, as the base maps themselves are housed on Esri servers. We will use a topographic base map for now by selecting Topographic and clicking Add. Now that we have a base map, these hydrant locations are starting to look good. Next, we will cover a few simple ways you can symbolize your data. Right-click the hydrant's data layer in the table of contents and select Properties. From the Layer Properties window, navigate to the Symbology tab. On the left, in the column under Show, select Categories. This will allow you to divide the data into categories and symbolize each category differently, as opposed to using the same symbol for all hydrants. Once Categories has been selected, click the drop-down menu under Value field. Here, we are selecting the field from the Layers Attribute table that we will use to symbolize the data into categories. We will select the Manufacturer field to symbolize the hydrants by their manufacturer. With the field selected, we then click the Add All Values button on the bottom. This adds each unique value from the manufacturer field in the Layers Attribute table. We can then assign new symbols to these values by double-clicking the symbol shown next to each value in the center. This opens the Symbol Selector window where a new symbol may be assigned. We will give each manufacturer a new color and increase their sizes a little so we can see them better. Using the Identify tool, we can see that the symbols have been applied correctly. If you would like to use custom or predefined symbology, you can import symbology from a .lyr file. We will do this using a .lyr file we have already created for this purpose. To do so, right-click the Hydrants layer in the table of contents and select Layer Properties. Back on the Symbology tab, click Import in the upper right. On the Import Symbology window, leave the first radio button selected that says Import Symbology Definition from another layer in the map or from a layer file. Click the yellow folder icon to browse to the location of the .lyr file that you would like to use. In this case, we will select our waterhydrants.lyr file and click Add, and then click OK. The symbol from the .lyr file is shown in the center, and by clicking Apply, all hydrants in the layer will be drawn with our custom symbol. Next, we will cover the basic process for mapping our data in Google My Maps. Google Maps and Google My Maps are different sites. On the My Maps homepage, select Create a New Map in the upper left. This opens up a new map with a base map and one empty data layer. You can switch between a variety of different base maps using the Base Map drop-down menu on the left. To add data into the empty data layer, click the blue Import button under the layer's name in the table of contents. The import window tells you which file types can be used with My Maps: CSV, XLSX, KML, or GPX. You can drag and drop the appropriate files here to add them to the map, or click the blue Select a File button to browse to the data. We will browse to the KML file we downloaded from Fulcrum. After selecting the file, the data is added into our map. Using your mouse scroll wheel or the plus or minus buttons in the bottom right will allow you to zoom the map in and out. In the table of contents on the left, we can see all the points in this layer. The data we collected for these points can be accessed by clicking the menu button to the right of the layer name, represented by 3 vertical dots, and selecting Open Data Table. The Individual Styles button under the layer name gives us options for how to symbolize the data. The Style Data by Column option allows us to select an individual field from the data table and symbolize the data based on those values, like we did with the manufacturer field in ArcMap. For now, we will select Uniform Style, which will allow us to apply the same symbol to all points in the layer. In the table of contents, where each individual point used to be listed, it now says All Items. Using the Paint Bucket button to the right of All Items, we can set symbology for the layer. Here, we can change the point's color or select from a few popular icons. The More Icons button on the bottom shows you the full list of icons native to My Maps. To use your own custom symbol, click the Custom Icon button on the bottom left. This opens the File Import window. Just like when adding data to a layer, you may drag and drop the appropriate file here or browse to it by clicking the blue Select a File button. The file types that Google My Maps will accept for symbology are image files, such as JPEGs or PNGs. We will browse to the image file we want to use for our point symbol, in this case, our hydrant PNG image. After the image file has been selected, you can see our new custom icon in the list of available icons. With our new symbol selected, clicking OK applies the symbol to all points in the layer. When you have completed building your map, you can share your finished product using the Share button on the table of contents. After clicking Share, you will be asked to provide a title and description for your map. Next, in the Sharing Settings window, you will see at the top a link to your map has been generated. This link can be shared via Gmail, Facebook, or Twitter using the buttons below your link, or you can copy and paste the link directly. You can configure the privacy settings for your map in the Who Has Access section. You may also invite individuals to view your map by name or email address in the Invite People section. Clicking Done will apply any changes you have made and send invitations to view your map to the users you have specified, if any. We start with the
Whoop. So, hopefully that demystifies things a little bit. Obviously, there's a learning curve for all of these things, but I think Luke demonstrated there that once you know what you're doing, you can actually take information and turn it into something useful fairly quickly. And again, if you're just starting out and you're sort of more focused on being able to find assets out in the field, the Google My Maps option is a really great way to go, because if you're looking at that on a smartphone, that little blue dot that follows you around whenever you're looking at your smartphone, Google Maps application shows up on that map. So it's a great way to make it easy for your staff to navigate around to find your assets. And again, it's low barriers to entry. It's relatively easy to learn how to use those things. And obviously we're here to help as well. So again, just a quick demonstration of sort of the mapping side of inventory. I think you can see how the two of those things kind of go hand in hand. And like most of asset management, what we've been talking about all day today is really knowledge management, and that's sort of the underlying or the underpinning concept for asset management. This is all about taking information that is held by different people in your utility, whether that's notes on somebody's truck, information in somebody's head, information that's in existing databases, and documenting it, writing it down in a formal way so that it can be used by others. And then digitizing and combining that information, whether it's through a GIS or through a Google map or through an Excel spreadsheet. These are all different ways of doing it. The beauty of going down the GIS road is that not only is the information digitized, but you can use it to visualize and analyze it. You can do this on paper as well. I've seen a system that had their entire map printed out on the wall, and they used push pins to track brakes. And that is a very basic, very simple, and very effective GIS system. They were able to basically look at the wall and tell where the problems were. GIS is basically just a fancy way of doing that in the computer that allows you to do a little more slicing and dicing. The goal of all of this, the goal of asset management, the goal of mapping, the goal of building and maintaining an inventory is increasing collective knowledge. By doing these steps, you end up with a sum or a whole that's greater than the sum of its parts. And I think I showed you a couple of instances where you can use old information to create new information that you didn't have. It develops transparency inside the organization and really allows you to sort of maintain institutional knowledge, because when your staff leaves, they often walk out with a ton of really important information in their heads. And if you let that go, the utility will suffer. And the idea is to capture that and make it useful for everybody in the system. So with that, I'm going to say, I know that some of this stuff may seem a little bit daunting. It's really not that difficult once you get into it, and definitely don't let what you can't do stop you from doing what you can. If you don't want to get into GIS right now, that's just fine, but you can start collecting asset information and inventory information as you go forward, and work your way up to that. And even if you don't want to get into the world of GIS yourself, when you're doing projects with outside consultants, so engineering firms, maybe you add an extension to your system, make sure you always get a copy of the digital information that went with that project, whether that's a CAD file or a GIS file, because even if you can't use it now, somebody will be able to use that in the future. We spent a lot of time working on projects where if we had had those digital files, we could have basically pulled that information in and very quickly developed a whole set of information and analysis. But instead, we had to sort of start from the paper maps and work through the process that we showed you here, because the digital information that had been created either wasn't available because maybe the engineering firm had archived it or gotten rid of it after a number of years, or couldn't find it, or maybe it was available, but it was going to cost a bunch of money because it's work product. So when you're thinking about capital projects, even if you don't have the in-house capability to necessarily use the digital information that's developed, make sure that you get yourself a copy. And last but not least, whenever you're doing your mapping, whenever you're doing your inventory, make sure to keep updating it, because no matter how much effort you put into your map, if you don't keep it up to date, eventually it's going to be inaccurate. So I think we're exactly on time here. I'm happy to stick around and answer any questions if anybody has any. And I'm going to put up our contact information so that you can reach out to us if you've got questions about this and want to dig in further, got some questions about maybe some of the programs that we talked about or some of the techniques. So with that, I'll open the floor and do my best to answer any questions that there are.
Right now, we don't have any in the chat, but again, if you're typing right now, we'll stick around a little bit, but if you think of anything in the future, please feel free to email James or I, and you'll be hearing from me later today with that follow-up email. I'll also include the link to the asset management switchboard that James mentioned a couple times during his presentation. So thank you everybody for joining us. Please feel free to drop off if you don't have any questions, have somewhere else to be. We appreciate your attention for 2 hours. Thank you.
And again, you've got our contact information there. Feel free to reach out to us at any time about this. We, particularly Luke and I, really kind of geek out on this sort of thing. So we're happy to talk to you. And again, just through this EPA program that this is being presented under, there is that free technical assistance component. So if you've got questions about this, or as Haley mentioned, any other topic, rates, whatever, feel free to reach out to us and we'll put you in contact with the appropriate person to give you some help.